Okay, guys, I hope everybody hear well, and streaming working proper well. I really not know how to check that it's streaming working proper way. Um, so I will start. If we'll have any questions, you will write me in chat. Um, Hello, my name is Philip Goldman. I'm from EPAM. I'm solution architect, and my session will be, I think, in a minute to make sure that everybody here. Okay, welcome everyone to Java Z Day 2020. I really hope you're enjoying an online conference such as I do. My session will be about how to build stream applications with cost-effective and simple way via Apache Flink and Amazon Kinesis Data Stream, Kinesis Data Analytics for Java applications. I'm not going to talk about how to develop applications, Flink application. Instead of this, I will focus on how can actually build and operate my Flink application on AWS. Because of relatively easy to run Flink on dev environment, but it's much harder to actually run Flink in production. So in this session, I'm going to show you how to build simple Flink application based streaming application on AWS, and you will see what actual takes in your account, and you will learn how many services can help you to reduce operational overhead and as well usually required run Flink and jobs in productions. So you effectively focus on building Flink application rather than managing infrastructure. So we will build something live on stage, and the session quite light on slides, and I'm spent most of my time in my account actually build the architecture we're going to discuss. Okay, so let's assume for a moment we are on charge of operating analytical company, and would like to analyze online worldwide news about coronavirus. I think it's actual topic for making a demonstration and understand where we have more fake news or something like this. Um, we want to know frequently repeated news headers, geolocations of most producing news, and etc. Um, and we will analyze English content only for simplify our process for that session. Um, so how long it will take to build such a system for streaming application on premise? How expensive? How difficult to implement this? This is most important questions when we start thinking about that. And how actually we will build on AWS, I will show you right now. A central part of our architecture is going to Apache Flink, right? So Flink will take care of aggregating and analyzing data for us. But there are other parts we need to build as well, right? We need to service that will sniff online news of popular media services and submit into our Flink application. So we need some kind of ingestions layer, and we also need visualize results of our computation. So we need to some part of our infrastructure dealing with that as well. So I will start actually running Flink on AWS. Second. And there are a couple different ways how can we run Flink, Apache Flink on AWS. You can use EMR, you can manage through Kubernetes because Apache Flink officially provide supporting for Kubernetes. Built-in sessions and but in these sessions I will especially focus on Kinesis data analytics for Java applications, which basically managed by Flink offering. So a service does basically take care of provisioning infrastructure required to run your Flink application. So you basically give to AWS your jar file, the jar file of your Flink application, of course. And the service will then spin up all necessary infrastructure, then start Flink runtime, deploy your Flink application, and will set up checkpoints and save points. So in case of node goes bad, it will move workload healthy node and use checkpoints and save points to recover from failure. And last but not least, service also take care of scaling of your application. So in the example, what we're going to run through basically during night, there are much fewer news events. Then during the day, service will help us to basically scale our infrastructure so that there are only paying for resources that are actually required to run our Flink application. So at last but not least, we would like to persist results that being delivered by Flink application into Kinesis data analytics. I leverage service calling Kinesis data stream. In some kind of streaming, it's some kind of streaming buffer. Kinesis data stream is basically replayable ordered log, and you can have hundreds of thousands producers that send data in tracking that stream. Data is buffered by Kinesis data stream up to day and maximum to 7 days. And then you can have one or multiple consumers to read data of Kinesis data stream and process is actually. We would like persist results that have been delivered by our Flink application into our Elasticsearch service. 1 second. Ingest event data into Kinesis data stream from data by read our Flink application on Kinesis data analytics for Java application, and results sent to Elasticsearch. And we built Kibana dashboard and visualize data has been arrived to Elasticsearch. Okay, let's go ahead and actually build architecture in my AWS account, and I'm going to stop sharing my. I hope it's everything okay. So we will open our AWS management console, and we can open Kinesis services, and under Kinesis services we able to create Kinesis data stream, what we discussed earlier. We need to click create data stream. Then in data stream name we need to specify a name. Let's call Kinesis data analytics demo. Okay, then we need to specify shards. What does it mean, shards? for Kinesis data stream. This is some kind of containers that help you. Second, create new one. Yeah, looks better. Okay, so in one chart, it's gonna be produce data more than 1 megabyte or 1000 records per second, and read consume data by 2 megabytes as well, or 2000 messages in seconds. And if we will multiply in 2, it means that 2 megabytes for writing and 4 megabytes for reading. So in our demonstration, I will take 3 charts. Now, create a data stream. And for creating Kinesis data stream, it takes us less than a minute. After that, we will go forward. Okay, excellent. So Kinesis data analytics created. We will go to analytics applications. Click create application. We will specify same name like for Kinesis data stream, Kinesis data analytics demo. Right now, we need to specify type of runtime. Currently, AWS provides 2 types, SQL and Apache Flink. In SQL, what you're able to write your query on top of streaming data on streaming processing. Some kind of simple SQL queries. And Apache Flink that provide currently 2 versions, 1.6 and 1.8. For now, we will select 1.8, and we need to specify access permission. So what is it, access permission? We will provide specific permission for our Kinesis data analytics applications that will allow us to read from Kinesis data stream all logs and provide us access to write our aggregated stream into Elasticsearch. In our case, I already prepared it in advance with full access for our application, but for sure, in your case, you need to specify more accurate way permissions for your Kinesis data analytics. So let's create the application. It's created but not configured, and our next step is to specify all necessary configuration for created app. First step, we need to define where we store our jar file. I deployed already in advance jar file with our Kinesis Apache Flink application. It's an Uber jar file which include all necessary packages. So I specified S3 bucket. Then I need to specify the name. So I remember it's called like this, jar. Let's check the path was accurate created. Right, 29 megabytes, excuse me, 95. Okay, so next step, we already defined permissions for our application. Let's specify properties for that application. What is it, properties? In local way, if you run your Flink application, you will able to define all necessary keys and values during runtime, even during runtime of your app. But in AWS, in Flink, cluster Flink, in that AWS, you don't have access in runtime, and you need to specify in advance all necessary keys, and and it will be injected together with your Flink app. So what I'm going to do, I need to specify the name of Flink application, group ID, Flink application properties. Then we need to specify key for from where we're going to read our events. So it will call input stream name, and the name, if you remember, we created like KDA demo, right? Next, key where we're going to store our events, aggregated events, elastic search endpoint. And for endpoint, I also prepared in advance Elasticsearch. Why? Because for creating cluster on AWS, it takes approximately 10-15 minutes for deploying Elasticsearch. So what the Elasticsearch I deployed? It's a version 6. It's not so big cluster, and for large. I took 20 gigabyte and provide public access, and I created as well dashboard. So what we will do, we will copy endpoint for Elasticsearch, and let's check carefully that it's defined well, because if it will not be, we have to redeploy our Flink application, and I don't want to waste your time, guys. So I think it's created proper way. Click save. Yes. Okay, next step, we need to care about save point and endpoint. For save point and endpoint in AWS, it's calling snapshots. For developing purpose, I recommend you disable snapshots that help you to speed up your work, because it takes time for storing data and updating application. Monitoring. In monitoring, we have two groups of monitoring, metrics and logs. Both of them are ingest all metrics into AWS CloudWatch. So for metrics, I will specify here tasks. By default, there are 4 types of metrics, and I care right now to receive particular metrics per my task. Okay, so I enabling monitoring, and this about monitoring we will discuss in my next slides. But for now, let's I select debug. I will keep by default scaling, and I will click update. So what's happening right now? AWS checking our configuration, checking jar files, and preparing in Flink cluster all necessary configurations, and after that it's displayed to run. If we will click run, it will deploy our Flink in Flink cluster. So we deploy it, and for deploying and running, it takes us approximately 2-3 minutes for this process. Meantime, let's talk about our datasets. For datasets, I prepared in advance jar file that just read my datasets, what I downloaded from other particular service, data sets of news, and the jar file just implements situation when we our news services ingest data into our Kinesis data stream. So we just replace timestamp, but all data are in JSON format. So what are storing right now in S3 will be replayed by time. So I click run. As we can see, it's reading all events through S3, preparing, and let's see if it's starting sending data. Yes, excellent. So first events, what we ingest, it's 3,000 events per second we send into Kinesis data stream, and this is a good. Let's talk about our Kinesis data analytics application, what I prepared. What the source code I used, what I deployed in AWS. This is a simple Flink and stream app where we have simple logic. I'm going to show all logic are placed in a new stream. We have some kind of models for events and news. And what we have here, it's first step, we have to read parameters what we ingest into our app. If you remember, it was two arguments, inputs Kinesis data stream and Elasticsearch. Then we need to specify events time that we receive from JSON files, and then we prepare context of Kinesis that will be run and read data from Kinesis data stream. So this is a block of code. We just define the name of Kinesis stream and use data source such as Kinesis data stream. Now, next step is just to receive data set of news, and based on this to receive from Kinesis data stream, and then we need to aggregate based our logic, and logic here is simple, to group all and generate geohash code and group all events by that particular hash code, geohash code, which help us to mark in map. And second data set is just aggregate and count by popular tabloids headers of news what is most popular. Then with this data stream we just ingest into Elasticsearch without something specific things, right? So let's check what's happening in our Kinesis data analytics application. It's running, as we can see here. I'm going to reload the page. Okay, so as we see, it's run, it's read application graph, and as we can see here, we have our two data stream, and looks okay. So let's go to Elasticsearch. I prepared dashboard, and based our the dashboard we will see our results. Second, as we can see, everything works as we expect, and let's briefly explain what's happening in our dashboard. So we on map mark all popular news what created in in specific countries. And based latitude and longitude, we defined news, and based geo hash code, we specify what is most popular. As you can see, in that particular time is more created news in United States, especially in Washington, than in United Kingdom and China's as well, in Israel something we have. Okay, so in left bottom side, what do we see? We see how many news we received in current time. Okay, and bottom right side we see tags of popular news, what was we received in current time as well. Okay, so looks pretty okay, and let's try to specify situation that in Kinesis data stream we don't have enough time and not we don't have enough throughput for Kinesis data stream, and we need to do something in production, in on-premises production. Usually we receive some alerts and trying to understand what we will do, how can we increase all necessary resources and so on. In our case, we are not going to play with this. We just I just want to show you some metrics, important metrics for Kinesis data stream. As you see here, there is two lines. These lines what I am demonstrating on screen, it was before I just checked that it's worked pretty much well. And now this is our events, and unfortunately our events not so a lot of, and to reproduce situation when we have not enough memories for storing of logs, we can't. But as we see here, we have incoming data by bytes, and we see limitation, and limitations show us that we are situation when it's not enough storage. And what we will do in this case, we will go and increase capacity in double, that provide us scale, additional scale for our chart. And what's happened? Usually on production, in this situation, we have potential way to lose some events. But in Kinesis data analytics, all events will not lost and will be stored and will alive. Okay, excellent. We will wait a couple of minutes and let's move forward. Let's go to our application. 1 second. So let's check that streaming work in a good way. Yes. And let's open our slides. Okay. So let's quickly summarize what we just done, right? So we built fully managed end-to-end streaming application with scalable and high available, and the services are inherently tolerant for failure in case nodes fail, say, and replaced under the hood for you. There is nothing you need to do about taking checkpoints or configuring high availability guarantees. We ingested up to more than 20,000 events per second, and we built throughput architecture for all without losing single events. So just try to imagine what we have take us to build something similar from scratch on premises. Now I would like to discuss a couple of best practices when you are using services and show you a bit what happens under the hood. So you know how this architecture will react when you're scaling or of these kind of things, right? So first of all, Kinesis Data Analytics for Java application are managed service. So all operates all infrastructure and required run all your Flink apps, right? And it take care of operating Zookeeper, high availability, it configure checkpoints, save points, and handle automatic failover or scaling if you configure this. And basically scaling you did for Kinesis Data Analytics, it's Kinesis processing unit. So when you're running Kinesis data application, you need to tell AWS how many TPU should is it use, and the TPU basically give you parallelism of your application. So one TPU gives you one parallelism of one, and 8 TPUs give you a parallelism of 8. And each individual TPU gives you one CPU, 4 GB of RAM, and 50 gigs of storage. And by adding and removing this TPU, you can actually scale a Flink application under the hood. This works pretty well if you're CPU bound and maybe even if you're memory bound. However, if you're are IO bound and your Flink just basically dealing around waiting for your IO, you probably want to scale out further, and you actually don't need additional CPU and memory resources in this case because of you just waiting for IO. To apply our user case, you want to actually increase parallelism per TPU, which basically means single TPU can give you a cutter of parallelism up to 8, right? So not it's mean that not necessary to increase your TPU because of IO. So when you end paying for single GPU, but your Flink application can run with parallelism of 8. And so this is very important to know about GPU. So the service actually scale of your behalf regardless whether it's done automatically or manually, still Flink under the hood. So what happens if you stay in your trigger scaling operation basically cause some downtime for your application because of happens hood, and it triggers some save points, recovering application, and bring up new application and adaptate parallelism and resume from save point, and it takes minutes too, so you will some downtime in your application. And after scaling you can configure the after scaling, And basically, services will monitor CPU and of the cluster and use metrics scale your cluster in and out. So it will scale out guide greater aggressively within minutes, take more scale in mainly because of downtime. And you don't want to interrupt your Flink application too often. So there is one thing to watch of in this case, if your application is I/O bound, and what can happen in in AWS, well, to run your Flink application for KPUs with parallelism of 4. And so if you I/O bound are using service, please disable after scaling. So in this case, AWS will not scale in out themselves because of it make cause scale and of course money. When I created application, we already discussed quickly a couple of metrics to watch out for, right? So this covering more enter architecture rather than specific Flink application. And Flink will expose metrics operator level, and there are additional metrics that quite important to watch for. So Kinesis data analytics stream, Kinesis data stream. So in this case, we need to monitor incoming records and bytes metrics because of they tell you if you're approaching one of these limits and want to stay scaled proactively. Then there are also made metrics to tell you when you're actually already throttled as well, so you can rescale reactively, which may not best thing. And then there are very interesting metrics calling meals behind latest. So this is basically tell you number of milliseconds will consumer. So Flink application behind head of screen. So tell if your application, Flink application is lagging behind and so on. And what you can see in graph, it's basically scenario where running through the blue line indicates how many events sent to Kinesis data stream, and orange line is milliseconds behind of latest metrics. So basically what happened here is we are being ingesting events when I scale Kinesis data stream. So there has a lot of back pressure from these procedures. So number of events that are ingested into stream spikes, and the sum of points falls back and new baselines, which substantially higher than that before, as you can see on my graph. However, after scaling operation completed, Flink app starting fell behind, right? So let's talk about logging. You can also obtain your logs through CloudWatch, as we discussed. Two things are important. Please avoid extensive logging, in particular on data plane paths. So if you're logging ingestions, let's say up to 20,000 events per second, if we log each individual event, the login of system would be break, right? So what's not something you want to do. We use output logs, but we need to use output logs, but don't logs every event. This is dealing with because of increasing logging system with junk break, right? Data protection and security. A couple of things about this. And basically, you can configure all these services, encrypted data, rest in transit. So KDA for Java does do it by default. No need to specify in advance. But Kinesis data stream and Elasticsearch in our case can be configurable for encryption data as well. Um, Please avoid baking credentials in source code. Just use temporary credentials, what was attached in roles, what we defined. And based on roles, what we defined, we can read data, credentials data through particular properties, which calling set properties, constant, credentials provider after. So another important thing, such as connection strings to database and so on, please use some secret managers on AWS that help you to retrieve and rotate your passwords without storing in config files. So thank you very much, guys, and I hope you enjoyed. And questions? What's the selling point to Computation Spark, Kafka streaming, which also supported cloud environment? Good question. It's depend of specific situation. For instance, let's say that you're migrating your big project into AWS and you're already using Apache Spark with Kafka streaming as well, or without this. And in this case, if you have a lot of legacy code that have to be supported and you don't have enough time, you can migrate through EMR, what we discussed. And EMR provide all necessary infrastructure for Spark, Apache Spark. Comparison exactly safe point. I will give you one scenarios for this. To deploy EMR does not matter. EMR with S on EC2 or new way what we received on EMR 6, you have ability to deploy through Docker containers, right? Both of them solutions take more resources which you have to pay. In our case, Kinesis data analytics, you're paying only for specific job, and you can scale in and scale out based your specific job, and you can do it automatically. In case of EMR, it's a bit harder. I hope I answered on your question. How can you find new questions? Okay. Sergey, I hope I answered. If no, please clarify your question. Okay, there is another question. When better to use Kinesis data analytics for Java application? In case that it's similar question, but I think what Andre asked, Sergey, excuse me. There are situations when you need to control your process well, and you have streaming process that help you check other comments. Okay. Um, there is a situation when you run your Java application, and your Java application have to be deployed in 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 Kinesis Data Analytics, and this help you to specify a situation when if you have experience with Flink or no. If you don't have such as experience with Flink, probably need to think about Apache Spark and EMR. Situation when better to use KDA, it's for online streaming, for streaming based ETL processing, uh, and as well, Sergey, I don't see, unfortunately, and previous your message. It will be great if you will just write again your question, so I will see in my small chat your message. Thanks. Moving question from Pavel, we can use KDA in case when we have a big throughput and all events have to be controlled and no any losses, and all necessaries aggregating have to be completed and controlled through parallelism. In this case, I think it's better to use Kinesis Data Analytics for Java application. Questions? Um, Sergey, Pavel, if you have any questions, addition questions, please write in chat. Okay. Okay. Um, I think we're done. Thank you guys for your attention, and have a good day with other sessions. Thank you. Goodbye.